Hi, in today's video I'm going to go over drawing Lewis structures and the process that I think is the best for drawing them. So the first step is going to be to count the number of valence electrons, because this is going to be the number of electrons that you have to draw in the Lewis structure. So I'll run through a few examples. So nitrogen gas, N2. Nitrogen has 5 valence electrons, so it'd be 5 times 2, and you'd have 10 valence electrons. And again, I'm getting these numbers from the periodic table. Right? If you go across and you don't include the transition metals, you just go across the 8 columns that aren't the transition metals, and that's how many valence electrons it has. 1 on the left, down to 8 when you get to the noble gases on the right. Aluminum trichloride. Aluminum is 3. In chloride, there's 3 of them with 7 valence electrons to give a total of 24. Now, if you have a charge, so say NH4 plus, ammonium, a positive charge, you take away an electron. So this is going to be 5 plus 4 times 1, because each hydrogen has 1, minus 1 to give 8. And then if you have a negative charge, it's the opposite. You add an electron. So NO3 minus, it would be 5 plus 3 times each of the oxygens have 6 valence electrons, plus 1 to give 24. So notice with many of the common Lewis structures we'll be drawing, it's going to be an even number of electrons. Because if it's an odd number, that means it's a radical, and it's much more common to have stable molecules that are not radicals. It's a little rarer to have stable molecules that are radicals. So step 2 then, and this is best shown with a few examples of Lewis structures, which I'm going to do, is you have to give best guess for the central atom and draw single bonds to all atoms. So then that leads to step 3 then, being use all valence electrons by adding in lone pairs, or like a double or triple bond. But these second 2 steps, so step 2 and step 3, are best shown with examples. So example 1, it's going to be SOCl2. So first, counting the electrons, it's going to be 6 for sulfur, plus 6 for oxygen, plus 2 chlorides that each have 7. So that's going to lead to 26 total valence electrons. I'm going to guess here that sulfur is the central atom, because in general, the central atom is going to be the least electronegative of your atoms. So if we have sulfur, then I'll put an oxygen, chloride, and a chloride. I've used here 6 electrons, because there's 2 in each of these 3 single bonds. So I have 20 electrons left to use. Now, given that chloride is fairly electronegative, and it has 7 valence electrons, I want to give 3 lone pairs around each of these chlorides. Because if I do that, the formal charge of each of the chlorides is going to be 0. They have 7 assigned electrons, and they have 7 valence electrons. So that's my guess. And remember, with these Lewis structures, at the end you double check your structure to see if it's what you think could be the best one. So there's nothing wrong with putting that in now, and if we have to take that away later, we can. But oftentimes, any of the halides are going to have 3 lone pairs around them. So that was another 12 electrons I just used. So that leaves me with 8. Next up, I'm going to put at least 2 lone pairs with oxygen. Oxygen's never really going to have less than 2 lone pairs around it. So I'll put 2 there, and that leaves 4 electrons left. The sulfur only has 3 bonds to it right now. It needs to get that 4th bond. So if I put in that, oops, wrong color. If I put in a bond there, I now have a double bond. Another 2 electrons, that leaves me with 2 left. Okay. So SOCl2, it has an overall charge of 0, meaning that the sum of the formal charges also need to be 0. We already talked about how the chloride has a 0 formal charge. Oxygen has a 0 formal charge here because it has 6 valence electrons minus 6 assigned electrons. The 4 from the 2 lone pairs and then 1 from each of the 2 bonds, right, to give it 6. So my last pair I'm going to put in here on the sulfur. And now that also means sulfur has a 0 formal charge because it gets 1 electron assigned from each of the 4 bonds around it plus the 2 electrons from the lone pair. So this is going to be their best Lewis structure for SOCl2. All right, next example, HCN. So my number of electrons, I have 1 from the hydrogen, plus 4 from carbon, plus 5 from nitrogen, so 10. A lot fewer than we had before. Carbon is usually going to be a central atom if it's in a compound. So I'll put carbon, nitrogen, and hydrogen. So I've used 4 electrons, that means, with the 2 single bonds, and I'm left with 6. We can't draw any more electrons on the hydrogen. It can only have 2. Right, at most on it. It technically, when you draw this with formal charge, it would have formal charge of 1 minus 1 to give you 0, because it gets 1 assigned electron from that single bond. But you'll never see more than a single bond drawn to a hydrogen. Carbon will almost always have 4 bonds to it, because if it doesn't, it's going to have a formal charge, and carbons don't usually have formal charges. So I'm going to put in a triple bond here, because then that gives the carbon 4 bonds to it. So by doing that, I've used another 4 electrons, and I'm left with just 2. And I'll put the last 2 as a lone pair on the nitrogen. Now hydrogen has a formal charge of 1 minus 1 to give 0. Carbon 4 minus 4. And nitrogen 1, 2, 3 electrons from each of the bonds, plus 2 from the lone pair is 5 minus 5 valence electrons, 0. So this is probably the best structure because it has an overall 0 formal charge, and HCN has a 0 formal charge. All right, my last example, I want to do a structure that has a charge. So NO3 minus, nitrate. The number of electrons is going to equal 5 from the nitrogen, plus there's 3 oxygens with 6 each, and then because we have a minus sign, I'm going to have to add 1 more. So this is going to be 24 total. Very likely nitrogen here is the central atom because it's less electronegative than oxygen is. So take away 6 electrons because I just put those into the single bonds, and we're left with 18. All right, next step, like I mentioned in the previous one, it's likely that all of the oxygens will have at least 2 lone pairs on them. Right, for it to have less than 2 lone pairs, that would give oxygen a positive formal charge. And given how electronegative oxygen is, it's unlikely to have a positive formal charge. So I'm going to put 2 around each of the oxygens. So that's 12 electrons by doing that, leaving me with 6. We need to get 4 bonds to the nitrogen. So I'm going to make one of these a double bond. It doesn't matter which one I make a double bond. So say I make that one a double bond. That leaves me with 4 electrons. So I can put 2 electrons on each of the other 2 oxygens. But now when I do formal charge, I'm going to get a negative formal charge on that oxygen and a negative formal charge on that oxygen. The oxygen here has a formal charge of 0, right? 6 minus 6. But this nitrogen has a positive formal charge because it has 5 valence electrons. So for the nitrogen, it's 5 valence electrons minus 4 assigned electrons, 1 from each of the 4 bonds, to give plus 1 formal charge. So now my overall formal charge is equal to 1 minus 1 minus 1, which is negative 1. And that's what this molecule has. So how I finish drawing the Lewis structure then is I need to show that it has a negative charge overall. So I put it in brackets, minus. So that's how you draw the Lewis structure of a charged compound.